Today's lesson is on section 3.3, solving multi-step equations. This first part of the chapter we did solving one-step equations and solving two-step equations. Multi-step equations just means that there could be 3 or more steps. But all the steps we've learned up to this point are still going to be important. The same steps we've talked about when we're solving an equation, still going to be used in this section and the ones ahead. When we see that they're multiplying something to the variable, we're going to divide something to the variable. When we see that they're adding something to the variable, we're going to subtract. All things we've talked about in class, all things that we've done on tests, on homework, on quizzes in this class so far, in this chapter. But now solving multi-step equations, the only thing again that's going to change is some of the problems may take 3 or more steps. I've got a little checklist here, or a little list of what order you should go through steps when you're looking at a multi-step problem, and this is something I'd like you to copy down into your notes. So, steps to solve a multi-step equation. The number one thing, or at least when I'm looking at a multi-step equation, the first thing I'm usually going to look to do is if there's somewhere to distribute in that problem, I'm going to take care of that. And again, each one of mine says, number one step says distribute when possible. Again, that's important. I'm only going to follow that step, obviously, when that case is presented to me in a problem. So if I can distribute somewhere, and again, we've learned how to distribute in Chapter 2, I'm going to distribute in that problem. That's the first thing I'm going to do. I think that's the best way to get to the answer. Number 2, when I can collect like terms in a problem, I'm going to do that when possible. And also, again, I'll just kind of stop here and say this. This is just my technique for solving these problems. I think this is the easiest way to get to the answer when I'm doing a multi-step equation. I think this is the easiest set of steps to follow. There may be other ways to get to the answer sometimes. Sometimes you can do 1 and 2 out of order, or even do something else first. But I'm going to suggest you always attack a problem this way, and if this is the way you always do it, I guarantee you're going to get to the answer, as long as you follow these steps. Number 3. Get the variable on one side and then use inverse operations to isolate. That's essentially summing up the first things we've learned in this chapter in sections 1 and 2. We know get the variable on one side. We'll talk a little bit more about that too as this chapter goes on, but get the variable on one side by itself, and we're going to use the inverse operations to isolate. If they're adding, we're going to subtract to the variable. If they're multiplying to the variable, we're going to divide. So again, we do the opposite of what's happening. That'll get the equation solved for us and get x or y or whatever variable it is all by itself. Well, since I have the first step up there to solve a multi-step equation is to distribute when possible, we have to remember, what does it look like when we distribute? Again, we worked on this in Chapter 2. The times when we're going to distribute is when I have some kind of number, or when I have any number, or even a variable, but a number outside of a set of parentheses, and inside the parentheses, I have an expression. So let's say something like, well, there's a 2 outside of the parentheses here, and inside the parentheses I have 4x plus 5. When I see some kind of expression like this, we talked about how we can simplify by using the distribution property. What that means is I can take 2 and multiply times each of the terms inside this parentheses. Remember, when the 2 is right next to the parentheses as it is, that means multiply. So just think of this now as, well, I have to multiply times each of the terms that's in that parentheses though. I take 2 times 4x, that's going to give me 8x, and 2 times 5 gives me 10. So this becomes now 8x plus 10 after I've distributed. When I see some type of problem like this, or something like this in the equation I can do, that's going to be my first step. Again, I think this will help us get to the answer. That's number 1 on our list. So here's what number 1 looks like. Distribute when possible. It looks something like that. And again, we've done some of those problems, or actually many of those problems in class so far. Just did them in Chapter 2. We're going to bring that back now to Chapter 3. It's going to help us with these types of problems. Second question I have down here is, what does it look like when you collect like terms? We've been doing even more of this recently too. What does it look like when I collect like terms, or what does that look like in an equation? Well, it's always when I have 2 like terms that are added or subtracted together. So something like 2x plus 5x. I can add 2 and 5, the coefficients of these terms, and just get 7. And the variable stays the same because they are like terms. So 2x plus 5x gives me 7x. Or if I'm subtracting them, let's say it's 6y minus 4y. When I take 6y minus 4y, I just get 2y. So, again, we've learned how to collect like terms in the past. We've learned how to distribute in the past. We've learned how to do both these things. Here's what they look like. We're now just going to use these things also to help us solve equations. I'm just going to walk us through a few examples here. So what might this look like when we're solving problems today? Well, our directions, first of all. Our directions, let's say this is a few of our problems in our assignment. Our directions should say solve. I'm going to try to find out what the variable is, what x is, or what y is, what number is it equal to that makes the equation true. So it says solve. Again, I'm going to consult my list here when I'm starting out though. I'm going to say, okay, my steps to solve a multi-step equation. I'm going to go right down the list and see which of these I need to do and skip ones that I don't need to do in that particular problem, but it starts off here at the top. First I'm going to distribute. So as I look at problem number 1 here, do I need to distribute in this problem? I would say to myself, yes, yes I do. So right here, 2 times each of these things that are in parentheses, 2 times x and 2 times 3, or sorry, 2 times 4x and 2 times 3. 2 times 4x gives me 8x. 2 times 3 gives me 6. And once I've distributed, again, here's why I have this at the first step. Once I've distributed, you can even see right now, I've gotten myself into a problem that's really just like a 2-step equation, which is just like we did in the last section. So when we just did 2-step equations, we know how to do a problem like this. I'm going to draw my line. I'm going to try to get x by itself. It has 8 times x plus 6. So I'm going to subtract 6 from both sides. Gets rid of the 6's on the left side. 8x equals, well, now it's just 40. And divide both sides by 8, so I get x equals 5. So again, by distributing first, that sets something up for me that looked pretty familiar, and that's why I was able to solve that problem, again, using things we've already learned in the previous sections. I'll look at one more just like this, and I kind of skipped one thing in there, so I'll kind of make sure I mention that here this time in this problem number 2. Again, I'm going to go through my steps up here. Steps to solve a multi-step equation. It says first distribute when possible. This problem right here, I can distribute right here this number 4, to the things in parentheses here. I can take 4 times 3x and 4 times 5. 4 times 3x gives me 12x. 4 times 5 gives me 20, so it's 12x minus 20 now. That equals 16. I kind of forgot to mention this in the first problem, but now I should actually consult my steps and look at, okay, step number 2, do I have to do that? In this particular problem, there are no like terms to collect. I have 12x, I have 20. That's a term with a variable, and then just a constant. I can't collect those. I can't combine those things at all. So no, there's no like terms to collect on one side of the problem. So now I just go to step 3, which is get my variable on one side and use the inverse operations to isolate. So I'm going to draw my line. 12x minus 20. So I'm going to add 20 to both sides. That gets rid of the 20s on the left side. Now I just have 12x equals, well, it looks like 36 over on the other side. I'm going to divide both sides by 12. So x equals 3. Again, just kind of following my steps. I look at what I need to do in each problem. And going through steps 1, 2, and 3, I should be able to get to my answer. Again, especially I think, though, once you go through steps 1 and 2, these are just a setup to get us to something that we just worked on. So that's why I'm hoping those, if we do those first steps first, distribute and collect like terms when we can, that'll get us to a 2-step problem, which we seem like we're very good at. We're very comfortable once we get to that point in the problem. I'll look at number 3 here. Example number 3 says, well, it says 2x plus 4x minus 5 equals 31. If I look back at my steps, step number 1 says distribute, but in this problem right here, there's nowhere to distribute. So I can just kind of skip that step because there's no number outside of parentheses, nowhere to just kind of multiply things together. So I'm going to skip that step. I'm going to go to collect like terms, step number 2. On the left side here, there is a place to collect like terms. I can take 2x plus 4x and combine those. 2x plus 4x gives me 6x minus 5 equals 31. So again, step 2 I was actually able to do in this case. And that got me to a point now that looks probably, again, pretty familiar. This is just a 2-step equation. 6x minus 5 equals 31. I'm going to add 5 to both sides. Gets rid of the 5's on this side. Now I just have 6x equals 36. Divide by 6 on both sides. X equals 6. I'll just go through 2 more examples here. But otherwise, again, most of these problems, these are the 3 steps that I can follow to get me to my answer. And each problem I'm going to analyze it and say, okay, can I distribute? Then when I'm done with that, can I collect like terms? And then try to get my variable on one side and get it all by itself. So if I just kind of follow the steps on each one, this is what I'm going to do when I'm solving a multi-step problem. And this is what you should do from now on. Like, this is section 3.3, but whenever you're solving any kind of equation in the future, these are the 3 steps you should go through, at least that I recommend you should go through. There's sometimes other ways to get to the answer, But I guarantee if you follow these 3 steps many times when you're solving an equation, you'll probably be able to get to the answer. So I suggest distribute, collect like terms, and then go ahead and isolate the variable. So let's look at this example here. It doesn't have a number, but we'll look at this one. It says 2 times in parentheses x minus 6 minus 10 equals 28. In this problem, I'm going to go through my steps. Can I distribute somewhere? Yes, I can. Right here, I have a 2 outside of parentheses. So that means if I can do that somewhere in a problem, I'm going to do that first. 2 times x and 2 times 6. 2 times x just gives me 2x. 2 times 6 gives me 12, so this becomes 2x minus 12. Then I also still haven't dealt with this negative 10 here, or minus 10, and that equals 28. So that's what I've got on my next line. I distributed first. That was my first step. And now here's what I've got, my next line. Now I'm going to go to step 2. Can I collect like terms? Yes, I can. On the left side here, notice that I have negative 12 and negative 10. Those are both constants on the left side. That means they're also like terms. I can combine those. So I haven't done anything with the 2x. I'm going to bring that down to the next step. Negative 12 plus negative 10 gives me negative 22. And some people may be wondering, how did I see negative 12 and then negative 10, or how did I add those? Well, again, you can also remember that I can also just chop dash a number here to remind myself this is just like negative 10, and it's like I'm adding these 2 numbers together. So negative 12 plus negative 10. So that's how I knew to add those 2 negative numbers together and get negative 22. That equals 28. So I have 2x minus 22 equals 28. Now again, once I've gotten to this point, once I've gotten to step 3, I've done the distribute and the collect like terms. Now I'm just going to try to isolate the variable, just like we've done these first 2 sections, and like I think most of us are getting much more comfortable with doing once I get to this part of the problem. They have 2x minus 22. I'm going to add 22 to both sides. That gets rid of the 22s over here. Now I've got 2x equals, well, 28 plus 22 gives me 50. Divide both sides by 2. X equals 25. I'll go through one more example here with us. Again, just to kind of show us the steps one more time. But again, most of the problems, as you're going through the steps, that should guide you to the answer if you just take it step at a time. That's one more thing I have to encourage students to do, is just be patient with these problems. Even when I'm doing these problems, these multi-step equations, even I can't tell you what the answer is right now in this particular problem. I can't tell you what the answer is to this right off the top of my head yet. But if I go through the steps one by one, if I distribute, look to collect like terms, try to get the x by itself, then I guarantee I will get to the right answer. But I got to follow the steps to get there. So first step, I'm kind of looking up here for a second. My list says distribute first when possible. Right here again in this problem, I can distribute negative 3 times x, negative 3 times 3. Negative 3 times x gives me negative 3x. Negative 3 times 3 gives me negative 9, or it's kind of like, again, minus 9. Again, when you have a negative number, it's almost just like you're subtracting it, so I can write that too. Negative 3x minus 9. I still haven't done anything with this plus 6x. I still haven't done anything with this equals 18. So that just comes to the next line with me. And now I have negative 3x minus 9 plus 6x equals 18. Step 2 says, when possible, collect like terms. So as I go down here, can I collect any like terms? Yep, I have negative 3x and 6x both on this left side of the equation. So I can just collect those. Negative 3x plus 6x gives me just 3x. I still haven't done anything with the minus 9 yet, so that comes to the next line here. That kind of comes down here. And that all equals 18 still. Now again, once I've done those 2 steps, now it's just a 2-step problem to solve, which again is kind of like a review from the previous section. Add 9 to both sides. Gets rid of the 9s here. I have 3x equals 27. Divide both sides by 3. And I'm getting x equals 9. So again, these multi-step problems, again, even I can't see the answer right away necessarily in a lot of these. But if students and myself just kind of patient and go through the steps, these steps I guarantee. There may be sometimes other ways to get to the answer, but I guarantee if you follow these steps, you will get to the answer, the correct answer, more often than not. That's the way I suggest you go through a multi-step problem.